This new question is to solve differential equations with power series. You are asked to solve a first-order differential equation using a power series method, with a solution centered at x equals 0. The equation to solve is the derivative of y with respect to x equals 2 times x times y. And the initial condition is y at x equals 0 is equal to 1. First step is to assume a power series. We begin by assuming that the function y can be written as an infinite sum, which we call power series. That is, y equals c0 plus c1 times x plus c2 times x squared plus c3 times x cubed, and so on. This series continues with each term being a coefficient times x raised to an increasing power. Then, the derivative of y with respect to x becomes c1 plus 2 times c2 times x plus 3 times c3 times x squared plus 4 times c4 times x cubed, and so on. Next step is to substitute into the equation. Next, we plug both the original series for y and its derivative into the given differential equation, which states that the derivative of y equals 2 times x times y. So, on the left side, we have the series expression for the derivative of y. On the right side, we multiply the series for y by 2 times x, term by term. This results in a new series where each term is 2 times n times x raised to the power of n plus 1. Next step is to match the powers of x. Now we need to compare both series term by term, which requires all powers of x to be aligned. To do that, we shift the indices. For the left side, we let k equal n minus 1, so the new form becomes the sum of k plus 1 times c sub k plus 1 times x to the power k. For the right side, we let k equal n plus 1, giving us the sum of 2 times c sub k minus 1 times x to the power k. Now both sides of the equation are written in terms of powers of x to the k. Next step is to match coefficients. Since these two series are equal for all x, the coefficients of matching powers of x must be equal. Start with a constant term, where k is 0. On the left, we get c1. On the right, there's no term, so we conclude that c1 must be 0. Now for all values of k greater than or equal to 1, we equate the coefficients. K plus 1 times c sub k plus 1 equals 2 times c sub k minus 1. Rearranging this gives us a formula to compute each coefficient. C sub k plus 1 equals 2 divided by k plus 1 times c sub k minus 1. This is called a recurrence relation. Next step is to apply the initial condition and compute coefficients. From the initial condition y at x equals 0 equals 1, we know that c0 is 1. Since we already found that c1 is 0, we can now use the recurrence relation to find the rest. Starting with c2, it equals 2 divided by 2 times c0, which is